Hello there, my mate Vince here, and in this video today we're going to be fixing up, hopefully, a Milwaukee 18-volt charger, marked up as WAS1. And as you can see, when I plug my 18-volt battery into it, even though we're plugged into the mains, there's no lights lighting up. So let's bring it over to the mat and find out why WAS1 isn't working. Now, those eagle-eyed viewers, just like myself, may have just noticed something. I brought WAS1 over to the blue mat. And look, we have no fuse here. Now, has the fuse been taken out because maybe it's putting some weird short on and it's tripping the electrics? I'm not sure. Let's see. One of these is going to be going to here. The other one's going into the machine itself. Here, okay. So that one goes to here, goes through the fuse. So this is going down the wire into the machine. Let's see if we have a short, because I don't just want to put a fuse in. Why has it been taken out? Right, so there's no short there going into the machine. So I think, because look, there's no earth, I think we should be okay plugging that in. I don't think it's going to trip the electrics. And if I look really closely here, it's labelled up, it says 3A 250V underneath it. So I think I am just going to put a 3 amp fuse in. 3 amp fuse and a little cover as well. So let's pop that in here. Now, let's plug it in. I'm presuming anybody in the trade would fully know to check the fuse on a plug. Especially Stones. I hope this isn't Nick, this is an eBay special, so I hope Stonesy doesn't come after me. Now, let's plug it in and let's see if all the lights go out. I hope this doesn't trip anything. Plugging it in now. Okay, plugged in. There's nothing happening here. Plug this in. Okay, it's not doing anything. Right, let's... This is fully charged, but still, I'm pretty sure it would start charging again even just for like 10 seconds or something. Let's... I haven't got a 12-volt one to test. Let me just double check that it hasn't blown the fuse again instantly. In fact, I can do that without taking that apart by simply going on here and seeing if we're still in the megohms. Which we are, so we know now that the fuse is still intact. Excellent. Well, let's open this up and see if we can see what's wrong with it. They look like they might be Torx 20. So annoyingly, we've got quite a lot of gloop on the board here, but maybe I can test it from the other side. Let's try to undo these ones here. They're a smaller Torx. They look like they're Torx 15. Right, first thing I'm looking at is that thing there doesn't look very nice. I just want to zoom in just to make sure that is glue on the top. I think that's just glue on the top. So I'm just having a quick look, see if there's anything burnt. If not, I think we're going to have to start measuring fuses and stuff. That's not a cold solder joint, is it? Don't think so. Well, I think it looks okay. Let's just have a quick look on this side. So this is where the through-hole components are. So all the actual circuit board is on the other side there, and these are just through-hole components. So it looks like we have a fuse up here, and we also have a fuse here as well. Fuse 3, so there must be another fuse. I suppose we could check them to begin with. I'm wondering if one's for this, and then another one's for this one here. Let's try to fuse this. So on continuity, fuse is okay. That fuse is okay. Now there's a massive thing going across here, which I presume is going to be fuse 1, this big black thing here. Let's see if that is okay. No, it's not. So why has the fuse blown? Should we follow the circuit and see what's happening? So we've got power coming in here on the brown and the blue. So it's going to be this massive one here and this one here. So power goes from here through the fuse, and as you can hear, we haven't got anything. So this is going to be neutral, which it is, and this is live. What? There's a bit of an annoying connection there. So that doesn't get, so it could just be the fuse, but I would presume the fuse blew for a reason. So from here, you go through a coil. Do you not? There. Do you know what it is? There's some weird coating on this board. Annoyingly, the board is covered in conformal coating. Imagine it like a kind of varnish type thing. Great to protect the board from like moisture and dust and everything else, but it does make fixing it a lot more of a pain because my leads are so sharp and I'm having to really jab them in deep. In fact, remember I said the fuse was blown? Well, check this out. When I go back and measure the fuse again, it's okay. It's just I wasn't going on hard enough because the conformal coating is just everywhere on this board. And on the other side of the board, there's loads of glue everywhere. So you kind of can't win testing from either side. Hold on. The fuse is not blown. It's just it's just got annoying coating everywhere. The fuse isn't blown. Right, so we need to find out. We need to plug it in again. We need to see if the capacitor has any charge on it. So I'm going to plug it in right now. And let's see if that cap's got any charge. So I'm going to go to DC. I'm plugged in. Keep my hands well away from everything. Just going to try to go on here. Annoyingly, I don't want to push too hard because I get electrocuted if I slip. I can't tell you whether there's charge on that or whether it's just making a bad contact with the leads. Let's go to AC and see if we have charge here. Not charge, voltage. You know, I don't trust the board. I'm sorry. I just don't trust the board. Right, now that it's off, let's go back to DC and I'm going to press a bit harder. You have to press so hard on this board, I'm worried it's going to flip and then it'll end up falling on me while plugged in. There you go, 277 volts. So I don't have to plug it in now. I know charge is getting to the capacitor. The sponsor of today's video is PCBWay. It's very purple in here. Do you like purple circuit boards? They're usually more expensive, but not this September. PCBWay are offering purple solder masks without any extra cost. Yippee! But that's not all they're offering in the month of September. What else is PCBWay offering? They're offering discounts on flexible TPU. Vince, what is flexible TPU? Flexible TPU is a 3D printing material and it's known for its rubber-like elasticity, but yet it's tough and also durable. So it's like a hard plastic, but you've got the flexibility of rubber. And PCBWay in September have discounts. The higher the weight, the more you save. So you can save all the way up to 80% off. Now, if any of this interests you, check out the link in the description down below. Now, let's get back to the video. What I'm going to do next is I want to go from here, and just to make sure we definitely have continuity from these bits here right into the board. Right, let's try each of them. Which it is. Next one's yellow, which is the very tip here. So I test the rest of the wires and they're all testing okay. Yeah. So there's definitely no issue with the connector, the pins on the connector, the wires, or where the wires are attached to the board. We have continuity right from the metal prongs of the connector right the way onto the board. So that's all good. The board itself is all looking fine, so there's no visual clues to tell me that anything's wrong. What I'm now going to do is, I can see that there's 4 MOSFET-y type things. I'm going to test them for shorts. Right, should we try to measure maybe for shorts on here using diode? Right, so we have a reading there and a reading there. And let's swap the leads around. No reading. No reading. I can't tell you how hard you have to poke this board. No reading. Okay, My needle probes are so sharp, and yet I still have to stab at this, pick away at it like a demented madman. Anyway, as far as I can see, I think these MOSFETs are, I'm calling them MOSFETs, I don't even know what they are, but I think they're testing okay. So, let's turn to the FLIR, and let's see if FLIR can save the day. Right, I am going to use my FLIR cam. I can't see anything obvious on this. I bet one of the chips have gone. So we're going to do this side to begin with. We're going to plug it in, get the FLIR cam on the go, and see what it is doing. I listened to the comment section and I've covered all this up. It may overheat, but I've got 20 of them now, so it won't take me no time at all to put a new one on. If it does overheat, at least it won't short now, because before, quite rightly, if I was to put it down on something, it has exposed terminals, it's going to go straight across the battery and short. Right, let's plug it in now, let's see if anything is getting warm. Right, so we have a warm area across here, which interestingly is the bridge rectifier. But we know we've got voltage in the big cap, don't we? So maybe that heat's completely normal. Actually, let's see how hot it is. I'm going to bring my finger in, but obviously not touch the board. So you can see now that there's no heat there. A bit of heat down that way, not much. And even over here, there's very little heat there. Right, so there's nothing getting warm. I wonder, is there anything getting warm on the other side? I'm going to unplug it. Obviously, there's still loads of voltage in here. I'm going to gently turn it around. And let's see if anything's getting warm on this side. The reason I'm putting my finger in is because that will show true heat then, rather than just something that might be just a tiny bit warm. Right, so you can see FLIR cam, there's nothing there, there's no issue there. It's going to be a tough one. But what I'd like to know is where the kind of secondary side starts after this weird transformer, you know, the high frequency transformer thing, to see where I should be able to measure, you know, a lower DC voltage. Because then at least I could work out, is it a primary problem or a secondary problem? Because right now I don't know. See, I can't work it out because, for example, it could be this chip that's giving feedback and controlling this side here. Will we even have an output voltage if we don't have a battery connected? Do you know what? I have an 18 volt Milwaukee charger. I don't think it's this model number, but it's what I use to charge this one up. Why don't I get that, plug it in, and see what happens? See if, to begin with, see if it's got the same amount of terminals, and also see if there's voltage there when there's no battery plugged in. Maybe this thing only comes alive when there's a battery plugged in which case then that's going to be a lot harder than a normal switch mode power supply to fix, and switch mode power supplies are already a nightmare to fix. Right, so this one here is M12-18C and this is M12-18FC. This one does say rapid charge on it. Maybe that's the difference, but you can see they're nearly identical. And as well as that, this also just has 4 pins here. So now we're going to see if I plug this in, what happens. I don't actually know, do the lights come on or anything? Interesting. So let's remove this out of the way. So you can see now, hopefully, that there's nothing happening. So, have we got voltage here? No. No. Yes, 15 volts. Okay, so now I know there should be voltage on those 2 pins. At least I've got something to go back on. So 15 volts there. Nothing. Nothing. Brilliant. Everything's so much easier when you have a working product. Oh, and there's 15 volts on those 2 as well. Now, is there 12 volts up here? No. Is there 12 volts between one of them and the others? No. No. Yes, well, there's 4 volts there. Let's go on these ones. 4.9 volts. Okay, so at least I know now that there should be something happening. I'm going to plug this in. As soon as I plug this in, what happens? Green light here. I want to see if anything changes on these ones. No, they're still just 4.9 volts. Okay, so now I know I can trace it back. Every time we plug it in, I know I can trace it back from these two. 15 volts, brilliant. So now I measured a faulty board just to see what voltage we have on those pins. And instead of the 15 volts, we only have about 2 volts. But it's weird that we've got a certain amount of voltage. So it's not completely dead. It's like partially working, but there's only 2 volts instead of 15, which is really confusing. We have got some voltage. I'm unplugged again. Well, that's useful to know, but I traced it back from there, and the problem is it's just going all over the place. Transistors, resistors, diodes, capacitors. There's a lot of components on this board. It's actually quite complicated because not only do you have a switch mode power supply, you've also got 2 different circuits, 12 volts and 18 volts, and I presume it has to negotiate with the battery to charge safely. So it's quite a complicated little device. So what I do is, I know it's a different one, it's a more modern one that does fast charging, but I'm wondering if it's going to share some of the same components. In my mind, I'm thinking maybe on this one the main chips failed. I think it might be a chip problem because I can't see anything else wrong with it. So I take apart my working one and I'm trying to compare between the 2 boards. Ah, hallelujah, I found something, and it's something that possibly makes sense, and really maybe I should have checked at the very beginning. So we know that heat kills electronics, can kill electronics, because why else would they put these massive heat sinks in? It's to try to drain away all the heat. Now on the secondary side we do have something that I'm going to call, it's marked up as D7, I'm going to call it a diode, but I think they're both testing okay. But we also have a weird thing here. Now I'm going to call it a switching transistor, and it's switching this at high frequencies, on and off, on and off, on and off, this transformer thing. So, and maybe that is actually being controlled from this chip here. Maybe this is telling that how to do the switching. I don't know. But anyway, that's irrelevant for what the testing thing is here. It's got 5 legs on it. Annoyingly, they're in a different orientation. The switch is flipped on this one here. But if I take the reading from the negative of the capacitor, then you will see the difference. Now, the negative from the capacitor goes round and it goes to the right-hand side of the 3 legs. And if you have a look here, the same thing happens. The negative of the capacitor goes down and it goes onto the right-hand side of the 3 legs. So if I use my red lead to the negative of the capacitor, and if I go onto the right-hand side of the 3 legs, you will see that we have a full short. I hate these boards. What have I gone on? Hold on. I hate the boards because it's so hard to get a reading. There you go, you can see a full short, which is the same as if I do this, which you would expect because it's on the same track. And if I do the same here, let me get my bearings. So this is a negative of the capacitor, so right hand side of that one there, you can see full short. But now watch this, negative of the capacitor, the middle of the 3 legs. You can see I have a reading here, 0.5. And just while I'm over here, the left hand side of the 3 legs, I have a reading 0.7. Now watch this. If I go onto the negative of the capacitor and go onto the left hand side, you can see it's 0.7. So you're like, oh, that works. But now check this out. The middle should be 0.5. Look here. I'm jabbing that in as hard as I can and nothing's coming up. So if that is controlling the frequency of this, maybe if it's only partially working, that's why we only have 2 volts, while this one's fully working and we have 15 volts when it comes down to the yellow wire at the bottom here. Possibly. So we now know that it's either the traces which have gone to this, or it's the item itself which has gone, and the traces look perfect. And this is on a massive heatsink, so it's going to be getting incredibly hot, it's likely to fail, isn't it? So I'll tell you what we're going to do. Let's take this out and we'll see what the readings are. I might take this one out as well and see what the readings are here. If they're the same, which they probably won't be, but if they are, I might put this one in here, finish up the video and see if I can order up one for my working one. So I undo the screws and then I use my desolder station and I suck out all the solder from the legs on this chip. There is actually 6. I thought there was 5, but there's 6 legs. There's one little one out on its own on the very edge. So I desoldered the 6 legs and then I take off the chip along with the heatsink. That will then allow me to undo the screw without everything else being in the way, and I clean it with a little bit of isopropyl alcohol so we can get the markings from it so we can see what it is. Right, 1243 top 256 LN OP573C. Top. I've heard of that before and I don't know where. Right, let me Google that. It is a top 256EN. Miracles of miracles, you can get them. Look at that, 37p from AliExpress. I'm sure that's not going to be when you click on it. There will be something like minimum spend or something like that. But check this out. 195 delivery. That's completely believable. A lot of them are saying LCD power management. Digi-Key, see that's nice. So I don't want to spend £20 on delivery, but if there was other things to order, see I've just ordered a load of things from AliExpress and they all arrived ridiculously quickly. Within the week they all arrived. I've got loads of things. Check out these lovely new tweezers. So hopefully you'll see in future videos that I won't have bent tweezers. I've got lovely tweezers there. Nice tweezers here. And I even got some even better ones somewhere. Here, look at these ones here, mechanic. They're the ones that I've bought solder paste and solder mask from before. So hopefully they might be really nice to use. Look at how sharp they are. They're not going to stay long that way in my ownership. But it's good that you can get them from, you know, like Digi-Key and Mouser. Yeah. Okay, so that's great that I can buy one of them. Just to maybe finish off the video, and I feel confident that I can take it out without ruining my working one. Let's see if the working one's the same. If it is, I'll pop it in. If it's not, no problem. I'll put it back in here and we should still have a working one. So I take the similar chip out of my working better charger, the faster charger. Annoyingly, the chip's different. The chip from my charger is a top 261EN, and yet the chip from the faulty charger that I got from eBay is a top 256EN. Now I have a look at the data sheet and the differences that I can see are that the one that's in my charger is more expensive. So the top 261EN is more expensive, and the reason it's more expensive is because it's a better chip. It can handle more current. Apparently my one will do 333 watts, while the other one that came out of the faulty charger, the top 256EN, will do 119 watts. So in my mind I thought, well that's alright. I'll just put the bigger, more expensive, powerful chip into this charger purely to finish up the video, to prove that this chip is faulty and show you a working charger. Anyway, I pop it in there. Let's now cut to the bit where I'm going to turn it on. Obviously I'm nervous doing this because it isn't the right chip for this device, but as far as I can see, it's just a better chip that does the same thing but just handles more amps. Okay, will WAS2 come to life again? So I'm going to get an extension lead. Come on, you can do it. Well, I hope it doesn't... Should I plug it in first without the battery in case it has some almighty short? I think I should, because I can measure to see if we have 15 volts on here, can't I? Because it was these two. Right, let's get an extension lead. You can tell I'm nervous. Right, so I have my extension lead. I'm going to go across the room now and plug it in. and we'll see if it goes bang. Here we go, turning it on now. Okay, hasn't gone bang. I'm walking over to it slowly. I'm wary, I'm wary. Do we have 15 volts? You beauty, 16. 16 volts we have. Okay, I am now going to unplug it from here. I just want to see, does that 16 volts go away straight away? Or does it hang around a bit? It hangs around a bit. And now it's slowly draining away. Right, okay, let's be brave. Let's plug this battery in here. So we want to see, I presume because this is already charged, it might just be a green light. Let's plug it in now. I'm going to plug it in just into the extension lead. That's how confident I am. There you go. See, it went to a red light and then green. So green means it's charged. I can't test the 12 volt one. Actually, shall we see if we got 4.9 volts on here? It was here and here, wasn't it? Yeah, 4.9. Well, there we have it. I'll tell you what I'm going to do. I am going to do the screws back up so it doesn't explode, and I am going to try to drain this battery down a little bit. I've got a leaf blower. The problem is it's 25 past 12 at night. I'll tell you what it's very good for is getting rid of the dust from the radiators. My wife's been on about this for ages and she keeps wanting me to take off this top bit, but to do that I've got to slide up that bit there, slide up that bit there, and they kind of get jammed. And even then it means getting a little pointy stick with a rag on going up and down the fins on the inside. But this here, I can actually see bits of dust flying around the room. When you use this thing outside, it lasts minutes. When you use it inside, it lasts forever. Anyway, I've got it down to 1 bar. I feel confident now to plug this in right next to me. Maybe foolishly. Let's see, are you going to go to a green light now? Oh, did you see that? Whoa, Jesus. Whoa, whoa, whoa. Wow. I thought I seen a flash, and then boom, it went. Did you see that? Whoa! Ah, now I'm in a predicament. Is that, clearly it's gone, is that because... Is my battery still working? Yes. Amazingly, it's gone up to 4. It's, I presume it was only just, it might have only been just on 3. Oh no! Well, that's annoying. Is that because it's rated incorrectly? Or is something else on the circuit causing that to break? Well, let's find out. So after I change my pants, I then go onto Digi-Key and I order up some chips. Well done, Vince. So I started off with one working one and one faulty one. And now at this moment in time, I have 2 faulty ones. So let's pick up the video in a few days' time when my Digi-Key order has arrived.
A week later.
Right, it's about a week later now, even though the spares arrived quite a few days ago. This is my bag of chargers. So remember now I've got to fix 2 of them, not 1. But I thought to myself, you know what, Vince? Treat yourself. Digi-Key. Now, the problem with Digi-Key is, it's not that the prices are that much more, it's just that you have to spend quite a lot to get postage. I can't remember what the free postage was. Now, obviously, you can pay for postage, but that starts upping the price off it. So I thought to myself, okay, I think I had to spend £30-ish or something like that to get free postage. And I got all these. I think I got 2 off the ones for... mostly packaging. I got 2 off the chips for my working one, and then I think I got 5 off my other chips. So these are the 2 here, and I got 5 of these to fix ones in the future, or if I keep getting this wrong here. But I had to spend that still didn't come to over £30 as you can expect, because they were very cheap, a couple of pound each or something like that. But I thought to myself, oh, this looks nice, engineering kit. It was £30-something plus VAT, so I paid £40-something for this, and I thought, this is going to be nice. I'll get a whole booklet of capacitors. Now, this just shows you what a bargain it is when you get things from like AliExpress or even eBay. Because I got this and I thought, amazing, I can't wait. Having a nice thousands and thousands of capacitors. Are you ready? 40-something quid. Look what I got. Are you being serious? That and that for 40-something quid. I am absolutely gutted. Now, yes, I should have read the listing more to actually count how many things were included. I just assumed that if you were getting a book of capacitors, you really would get a book of capacitors, because I've seen other YouTubers use them, and it's a proper binder, and you flick through, and they've got all sorts. 2 pages for 40-something quid. I don't even want to work out what each capacitor is. I have since convinced myself that these capacitors are indeed a Rolls Royce of capacitors, and far superior to anything you would find on AliExpress or eBay. It's amazing what you do when you've spent a lot for something, how you justify that in your own mind to stop you crying deep down. So this video was filmed over 3 days, so I've got lots and lots of stuff to go through. What's happening now is I'm putting the correct chip in my working charger. I don't need to show you that because the charger was already working. It was me that took the chip out of it. So I put the correct chip back in. My charger is working perfectly again, just like it always has done. Why wouldn't it be? I took a chip out, I've put the same chip back in. So now I'm going to pick up the video after I installed the correct chip in the faulty charger, the top 256EN in the faulty charger. And then we're going to switch it on and I'm going to show you what it did. I did have a quick little look with the multimeter around the board to see if there was anything that didn't look right. And as far as I could see, the diodes and stuff were all testing fine. So let's pick up the video just as I'm about to plug it in. Okay, be brave, Vince, be brave. I'm going to plug it in without the battery. Last time it didn't go bang when I did this. Plugging it in now. I'm in. Stay away, stay away. Okay, hasn't done anything yet. Hasn't gone bang. Let's get the battery. I'm going to do this from a distance, scaredy cat. You ready? Please, please, please don't scare me. I'm in. We're red. That's good. We're ready. I'm across the room. Don't call me a coward. Fantastic. Right, okay, well, you know that we're on 3 lights here. Oh, I'm so nervous. You know that we were on 3 lights. I'll tell you what we'll do. Let's take that out. And let's see what voltage we have, because voltage won't lie, yet the lights will. Because remember, it could be 75% and above, and that light is going to be on. So I am going to go here and here. What have we got? 19.5828 dropping. Remember, it has just been charging. Look, 19.56 volts. So I'm going to plug this in elsewhere, and then let's see. Well, let's just do it here one more time. Let's see now if it. Ah, you git. You absolute git. Oh man, what's wrong with this thing? You're still not fixed.
A silly amount of time later.
Right, it's a couple of days later now. I had finished up the video, but things like this really irritate me when I can't work out what the problem is. So, like a demented fool, I've been looking over every single component on this board, probably for 2 or more hours. And I can't believe I missed this because there's such a big component. But I found something that isn't right. So maybe, fingers crossed, we can get this to work. Now, we know it's nothing major, so it's not going to be like a short because it is working. I've already put another one of these in. Another one of these now. Luckily, I bought 5 of them. So it's only after time, or I think before it blew when I plugged the battery in. So it's something to do with like surging. And I found something which isn't correct. It can't be correct. Look at this component here. It's massive. There's a huge resistor here. Massive, yeah? We've also got one here. Now, I know they're different markings, but they're still big, what look like maybe wire-round resistors, you know, ones that are good at dissipating heat. Now, if I was to go across this one here, it looks to be going from here to here. You would expect to see a resistance because it's a resistor. Here and here, you can see that we have 46 ohms. But now look at this. This one here, which is very close to this. You can see it comes from the capacitors and stuff here. You know, the main capacitor. If I go here, hold on. And it links to this area. So there's a diode here, which jumps across, goes down to here, and then there's a link wire, and it goes into that leg of the chip. So this resistor is connected to this chip via a diode. Look at this. When I go across here, I don't know how I didn't spot this before. It's in the mega ohms. And I think that's going to be on the board itself. I don't think that's correct. So let's pop this out of circuit. We're not getting anything that way. So I might even be reading like the capacitor next to it. Let's pop that out. I think that resistor's blown open. And luckily, I can read the markings on it, which is good. I hope this is blown open. I've spent way too long on this. I think it's just been held in by glue. There. Oh, hot. And I should be able to get rid. I'll tell you what we'll do to begin with is let's go straight on the board. We're in mega ohms on the board. So what have we got here? We have nothing. I'm on that good and proper. We have, let's use my fingers as well. We've got nothing. Yes! Right, let's see if I can work out what this is supposed to be. I don't think I'm going to have one. Right, blue, come on. Blue is 6. Grey, second one is 8. Orange is a multiplier times 1,000. And then I don't have to worry about gold, 5%. 1. Hold on a minute. So if it was that, it would just be 68 ohms, 680, 6,800, 68,000. So it's a 68,000 ohm resistor. Okay, and it looks like a massive one. So I don't know what watts that would be. So it doesn't tell you what watts it is, does it? But it's big. So I presume a tiny one like that, these are just going to burn up instantly, aren't they? Because these are only a quarter watt. Right, look at this here. AWR Freaks, and they've done the sizes here. You can see half a watt, 1 watt, 2 watt, 3 watt. I presume that's 5 watt. And the length of them, 11, 15, 17, 24. So if ours is roughly 15 mil or 14 mil, then it must be a 2 watt resistor. So I think I need a 2 watt 68k resistor. There we go, I've bought them. I really am a sucker when it comes to kits. I know I could have bought 5 of them, which would probably still last me my lifetime, for £3 on eBay, but having all the other assortment of stuff, it means maybe in a week's time or a month's time or a year's time, I can go back into the kit and get the correct resistor that I need, because I hate waiting on spares all the time. And when you do a variety of different things like me, you very rarely have the spares. Anyway, when this arrives, I'm going to pop it in. Fingers crossed now that we've actually found something else which isn't right. This will now be working, surely. Humour me for a minute, I'll fast forward through it. I just want to see if we can find out where it's broken, because there's definitely a wire round resistor. I can see all the wire here. So we might be able to find where it broke. It's always good to pinpoint the actual failure rather than just saying the resistor failed. Why did it fail? Now, while I'm doing that, I'm going to shout out them My Mate Vince Massive. The members this month are Keymon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJVG, Pigsy, Anthony Dean, Russ Melanson, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from The Broken Past on YouTube, Lee Benz, AJ Computer Services UK, and David Delay. Massive thanks to each and every one of you.
Well, that looks as solid as could be. Can't see any burn marks in that whatsoever. Right, let's get the multimeter and see if we can follow from the on continuity, see if we can follow from here going across. So, yes, yes. No, so nothing there. Let's see if we've got this one. Of course, hold on, we're not going to have continuity at 68,000 ohms. Let me just go to ohms and see if I can get a reading. Yes, that's 3K. Right, 3K there. Let's go to the next one. 14K. This is quite nice that you can do it as you go along. 26K, 37K, where are you gone? 49K, gone. So here we have 49K, here it goes to meg ohms. Let me just zoom out, show you that, and then we'll zoom back in again and see if we can actually find where it is. 5K, next one. 14, 24, 35, so it's grown by 11, is it? 47, now nothing. So it's in between that one and that one. Let's zoom right in and see. Oh, lost it. I think it was that one. Let's see what we got. Where are you blown? That's good. That's good. That's good. I wonder, is it a coating, a carbon coating on here, or is it the actual wire? Because it looks very thick, doesn't it? I wonder, is it the carbon coating that's burnt off? Let me see if we have continuity between here and here. No, we don't. So it's an ohm reading. It must be some sort of carbon on it that it's getting the reading off. And maybe the carbon just burnt away. Yeah, that's like 1K there. So if you asked me before this video, how is a wire wound resistor done, I would have said that it was a thin bit of wire wrapped round one side to the other to then create resistance in the wire itself. I didn't think it was to do with coating on the wire. I didn't know that. I don't know if that's common or not, but I think that's what's happening here, because the metal itself looks very thick, but it seems to be that the coating on the metal is what's giving the resistance, and maybe they can put a different amount of coating on to create different resistance. Maybe all these kind of bigger resistors, these 2-watt ones, are a similar design and they put a thinner or thicker amount of carbon on to get the different resistance. I'm not too sure. Anyway, a bit of a big brain moment hits me. I think it'd be more fun for the video if we try to fix this resistor up. So I bought some conductive paint ages ago when I did the massive keyboard with the little drum bits on the bottom. I bought loads of different kind of conductive inks and carbonized stuff back then, and this particular one I got off eBay, and amazingly when I opened it up, even though I've never opened it, it's still nice and liquid. So I put a bit on my mat and I just dab it all the way round, and I presume when it hardens it's going to leave a carbon film. Now I don't want to wait ages for it to harden, so I'm going to just use some 100 degrees Celsius, that's the lowest my hot air station will go, and I'm going to dry it with that. Then once it's dry, I'm going to measure resistance across it to see if it's anywhere close to 68,000 ohms. Now when I'm putting the ink on, the carbon ink, it does spread a little bit between two of the bits of metal, so that's going to create a short there. So when it's dry, I actually scrape back around each bit of metal to make it like a nice spiral again, and now we're going to test it. Now I must stress I have bought the correct resistors. I'm doing this purely for the video, a bit of a learning exercise and to make the video more entertaining. Is it possible in an end of day situation, end of the world, apocalypse type thing, and yet you're desperate for, even though there's no electricity, you're desperate for your Milwaukee charger to be working, then, well, actually there could be electricity if you have solar panels. Would you be able to get your Milwaukee charger working again by fixing a wire wound resistor? Of course you'd have to have conductive paint and all the other necessary equipment. Humour me. Well, that looks quite nice, doesn't it? I did slip a couple of times, so I might have scraped across them. Let's see if we still have resistance. No way. No way. 68,000 ohms, which is what it should be. I think I'm going to pop this in. And then what we'll do is we'll insert, I'm going to wear my battery down a little bit by putting it in the air blower, the leaf blower. And then I think I'm going to cover this with... what should I cover it with? What shall I cover it with? Because it's got a kind of ceramic-y coating on to let the heat out. Well, you know what? I'll leave it as it is. I wonder, will it burn up straight away though? Well, surely it's going to release the heat better like this. Because I'm not keeping it. It's just to see if it works, because it's funny. So I solder it back in and then I put it roughly back together. I don't do up all the screws. Let's insert the battery numerous times to see will it blow instantly again, or has this bodge on the resistor fixed it? Got 2 bars there. I've done a little bit of blowing around. What I've done is I've blown all the leaves over to the next door neighbour's garden, and then what they'll do is they'll blow them all back again later on in the week. And that's the great thing about leaf blowers, it gives people a constant job. So I am going to plug this in. Let's see what's going to happen. Is it going to last at all, or is it going to blow straight away? Right, I'm plugging it in now. Here we go. I've only put a couple of token screws in it to hold it together. 2 bars. Red, that's good. Now, the foot... Oh, it's not happy. Is that because the battery's warm? It could be because the battery's warm.
2 minutes later.
I'm getting bored. Come on. Excellent. Right, so it appears to be charging. Now I know I'm tempting fate here, but I think I'm going to unplug it. Unplug it in again, because I think the first time that's how it broke. I'm going to do it one more time, and then I'm going to leave it plugged in and see if it will get all the full charged up fully. I think we might have found the problem. Come on, Waz1. You beauty. I'm going to do it one more time. This is where it's going to go pop. Actually, let's take a voltage reading on the battery as well. .45 volts. 18.45 volts. Fantastic. Okay, I am going to plug this in elsewhere now, because I'm going to turn off the lights and everything, and then we'll come back and we'll see if it's going to fully charge the battery. Right, I'm going to do it here because if it goes up in flames, then there's less. It's not on carpet or anything, so there's less things to worry about. Right, okay. That's fantastic. That's amazing. So maybe that resistor is, it was something to do with surge, I'm sure about that. Because when you plugged it in, you're going to get a sudden, you know, a sudden surge. And maybe the resistor just dissipates that. I think this is going to work. Right, I've got to wake up the garden because you really think I was going to blow it next door. Of course not. I am absolutely dumbfounded. I've raked up the garden. It's been about 20 minutes, I would say, and it's still charging. That's crazy. So I actually do think, I think it's fixed. I'm going to leave it charging, just make sure there's no abnormal heat. Yeah, I can feel heat, but it's not, it's just warm. I think that will go to green. Brilliant. I'm willing it to go green, it's still red. The battery isn't red hot though. So, but there's definitely heat being generated from here. I'm praying that it goes to green. Oh my God, oh my God, oh my God! Look at that, it has gone to green. Mental. It's fixed, I'm sure of it. Oh, that is great news. Do you know what? I'm not going to measure the voltage. You can clearly see there's 4 lights there now, so you know that's going to be up to, I presume, 21 volts. Actually, I am going to, because I measured it before. 1 minute. What we got? There you go, 20 volts, 0.77. Fantastic. Oh, that is so, so good. Now, I wonder if I put it in now, I suppose it will be red again, but not for very long. There you go, straight to green, actually. Oh, that's great news. Absolutely fantastic. So, it was the main chip that was faulty, but then the reason it kept on blowing was because that resistor had gone. And how nice was that fix? Obviously, I'm not leaving it in there. You've seen that I've ordered the right ones from Amazon. I would never leave that in there. But isn't it nice to see a wire round resistor get repaired? And what I learned is, I thought it was the wire itself. It looks like it's the carbon on the metal that's actually giving you the resistance. I really enjoyed that one there, and fixing the resistor there was the best part of it. So when the proper one arrives, I'll pop it in there, but to see something like that get repaired with a bit of conductive paint, in my opinion, is it's joyous. If you could see my face now, what you would see is a right smug git. So I'm going to end the video now, otherwise you'll end up all hating me. But yeah, thoroughly enjoyed that one there. And I will see you again in the next one. If you did enjoy it, give it a thumbs up, because lots of you don't bother thumbs up in the videos. And I never really ask for it that much, but I think it does help push the videos. So yeah, my channel could do with a little bit of a push. So if you could all give it a thumbs up if you have liked it. And you never know, this video might get more views then, and then it might make my channel grow a little bit more. Thanks everybody, I'll see you again very soon in the next one.
Appalachian sunrise meets my skin. Even with my eyes still closed, I can feel it coming in. Golden, golden, I'll follow only golden, 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 golden things. Mountain laurel high fives for miles in spring. Rainbow trout and a hummingbird wing. Golden, I'll follow only golden, golden, golden things. Gold hair.